Hello friends, this is BK from Anika. I am here with a very interesting video. Today we will look into the performance of any computer science algorithm, and in technical terms the performance is called the finding the complexity of the algorithm. So before diving deep, let's go with the intro. So let's look into the complexity of an algorithm. The complexity is calculated to find the performance of the algorithm. So before diving deep and understanding the computer science terminologies of finding the performance, let's take a real life example. So for example, you want to make a cup of tea. Uh, what are the different steps which involve in this process? Can be six steps. First, boil water. In the second, put some tea leaves into it. Third step could be add some sugar. Fourth step could be add some ingredients like ginger or tulsi leaves or any other ingredients based on your taste. Then fifth step could be adding some milk. And the sixth step and final step is boil that mixture for some time. So in this process, and this is the same as the algorithm steps. So in this process, there are some time is taken for this and some cost is involved in this process. So for finding the complexity of this algorithm, and here the algorithm is the process of making a cup of tea. We look into the time performance. Let's say in the first step, which is boiling the water, it takes, let's say, 2 minutes. And then the second step was put some tea leaves. It, let's say, it take 20 seconds, and the same goes for third step, adding some sugar, let's say 20 seconds. And fourth step is adding some ingredients like ginger, tulsi leaves. Let's say it also take 1 minute, because there can be multiple ingredients that need to be added. And the fifth step for adding milk, let's say 20 seconds. And then at the final, we want to boil this mixture, let's say it take 2 minutes. So overall this whole process take 6 minutes, and we can say the time complexity or the time performance for this algorithm is 6 minutes. And there can be some better algorithm or better processes to make the tea, and which can have a lesser time. So depending on how what algorithm you are employing, it could have the different time complexities. And if we look into the cost complexity, so let's say there is some cost involved for boiling water and boiling the mixture, because gas is involved into it. And we are adding some we are adding some other ingredients like tea leaves, milk, sugar. All this have some cost. So overall if we add up all this cost, this will give the cost complexity of this algorithm. So this is the general uh, algorithm we have looked. Now let's dive into the computer science specific algorithm. So here on the screen you can see some code. We have defined an array of 2 dimension, 10 by 10, and we have written two loops, for loop, and I and j are the two iterators which are iterating on this array and populating the whole two-dimensional array with some random variables. So if you see this code and try to find out what is the time complexity or time wise performance of this algorithm, of this code. So you can see in this algorithm we are iterating on the two-dimensional array. So if there are n number of rows and n number of columns, then we are iterating n square times. For each shell, we are doing some processing. So we can say the time complexity of this algorithm is O n square. Now you are might be wondering what is O and what is n and what is this square and what does that means. So let me explain one by one. Here you have n square elements, means n into n. For each row we have n columns. Same for each cell, means each cell of that array we are doing some. So here for each cell we are finding a random number. So let's look into the space complexity. So for this whole code we are consuming n square elements, and this array could be of integer type or float or string, whatever, and we are consuming that much of memory. But in general we are squaring n square. But in general we are consuming n square, and that could be into 8 if it is, let's say, integer or float. Based on the size of these types, we are consuming that much of memory. So we can say the performance of this algorithm, the complexity is O(n) square. Now let's take a look into the different notations that we have. So while calculating the complexity of algorithm, there can be a requirement of finding different type of complexities. For example, the best case complexity, the average case complexity, and worst case complexity. So these are represented by different variables. So the best case complexity is represented by omega. The average case complexity is represented by theta, and the worst case complexity is represented by big O. But in general interviews and coding rounds of different companies, generally big O notation is considered because that's the worst case complexity, and as a developer you are more concerned about the worst case. So before closing this video, let me give you a challenge. You might have heard different type of sorting algorithm, and these algorithm could be of different complexities. You might have heard bubble sort, quick sort, selection sort, heap sort, and many more. So let's take a quiz and comment in this video what sorting algorithm you know, and what is the time complexity and the space complexity for these algorithm. Please let us know in the comment section, and if you have any other question, please let me know in the comment section. Please like and share and subscribe this video. With this note, BK from Anika is signing off. Thank you.